Now we know from last lesson that for two triangles to be congruent, their three corresponding sides all have to be congruent, but also their three corresponding angles all have to be congruent. So it wouldn't be enough just to know that I was going to make another triangle with three congruent sides. I wouldn't be guaranteed to know that those were going to be congruent, because when I put them together, I could definitely make different angles, right? I wouldn't have to make those same angles. So I could put this together with any sort of angles that I wanted to, and when I snap it together, I wouldn't be guaranteed that those three angles would match these three angles, right? Oh, but I just did. Was that just by coincidence? Or am I kind of forced to do that? Was it just because maybe if I twist them the other way? Now, are those congruent triangles? The angles still match. So there's actually a postulate in geometry that says that as long as you have, for a triangle, three sets of congruent sides, you're already guaranteed that the angles will match. So all you need to check for is that your three sets of sides are congruent. The lesson today is called Proving Triangles Are Congruent by SSS. SSS stands for the Side-Side-Side Congruence Postulate, which just says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Why is this so exciting? Because it's going to save us half the work. We used to have to list all three sets of corresponding sides and all three sets of corresponding angles that were congruent, and now we only have to list three things, just the corresponding sides. That's amazing. Have you ever noticed how bridges are built with like these triangles involved? Have you ever wondered why that is? It's because that it makes them super sturdy. I made this other little model and it lines up pretty nicely, but it doesn't have the triangles. So what's the benefit of the triangles? Well, this one, if you notice, it's not as sturdy. Do you see how it just has this collapsibility that the triangular one doesn't have? And that's related to today's lesson. The triangular one can't collapse. I've got some other figures here, and I was wondering if you could tell me if they were going to be collapsible or not. What would you say on this one? Collapsible? No, pretty sturdy. How about this one? Collapsible? Oh. The triangular side is pretty sturdy, but this other side, collapsible. This one? Oh goodness, no. That one's a mess. Now the reason that triangles are so stable is really because of the side-side-side congruence postulate. Because the side-side-side congruence postulate guarantees that those angles are going to be fixed, where there is no side-side-side-side congruence postulate for four-sided figures or five-sided figures. Those angles can be bendy. We can switch up those angles. So that's the reason that those triangles are so sturdy, is because of the side-side-side congruence postulate. A lot of people finally get into proofs in chapter 4 because they finally wind up being so repetitive and so simple that they're easy to love. So here's a proof. It tells us that side FJ is congruent to side HJ, and that G is the midpoint of side FH, and we are to prove that those triangles are congruent to one another. I like how on the picture they've already put the tick tick on that given, and actually since we already have one set of sides on those two triangles marked congruent, I like to put a little S off to the side because I know that my goal is to get three sets of sides marked congruent, and that helps me keep track of whether I've mentioned all three sets. They haven't given me any other sets that are congruent, but they have given me this very valuable piece of information that I have a midpoint. So I know that I'll be able to use the definition of a midpoint. Let's do that one even though it comes later in this proof. If I know that G is the midpoint of segment FH, doesn't that give me congruent pieces, can't I say that this piece is congruent to this piece? So that's what I'm going to put on that line. I'm going to say that FG, that segment, is congruent to segment GH. And the reason for that was because I knew that G was a midpoint. And I ticked that on my triangles, so I have another set of sides that are congruent. What's my only set of sides that I haven't put tick marks on? It's kind of the side of the triangle that they're sharing in the middle, right? They both have side JG in the middle. So would you say that side JG for triangle number 1 is the same length as JG for triangle number 2? Of course, because they're the same segment. Can't we always say that side JG is congruent to side JG? And do you see why that would be called the reflexive property? We've never used that in a proof before because it's always seemed so lame, but here is where it becomes useful when we're proving that triangles are congruent. Side JG is congruent to side JG. They're sharing that side. There's our third set of sides that are congruent. It's that shared side reflexive property. Now that we've got all 3 sides marked congruent and in the proof as proven congruent, now by the side congruence postulate, we can say what we set out to prove, that triangle FGJ is congruent to triangle HGJ. What a good time. Let's try another one. We know that side GE, let's mark this as long as we know it. We know side GE is congruent to side TM, and we know that segment GT and segment ME bisect each other. And we're trying to prove that we have congruent triangles. So we've already got one set of sides proven congruent. I'm going to put my little S out here because I know that my goal is to get 3 of those sets of sides proven congruent. I've got a vocab word in the given. I've got some segment bisectors going on. They're actually bisecting each other, so that's technically 2 bisectors. So I'm going to be able to use that reason twice. That was just a shortcut for saying GT bisects ME and ME bisects GT. So if GT bisects ME, that means that ME gets cut in half. So we could say that EO is congruent to MO. And that's another set of sides that are congruent. ME bisects GT, so that means that GO is congruent to TO. Our final set of sides that is congruent. Again, once we have all 3 sets of sides marked congruent, we are ready to say that the triangles are congruent. Triangle GEO is congruent to triangle TMO. And the reason is the side congruence postulate. Let's get our reasons list updated. Our very first way that we can prove triangles are congruent is by the side congruence postulate. And if you flip to that next page, you might just want to label those top set of triangles SSS, and let's put some markings on there for what we'd be looking for. We'd be looking for 1 set of corresponding sides marked congruent, 2 sets of corresponding sides marked congruent, 3 sets of corresponding sides marked congruent. That would be a picture that screams SSS Congruence Postulate.